morning students. Today's topic is differentiation. Differentiation means the rate of change of a variable with respect to the other variable. Here the question is x is equal to 2at square. If x is equal to 2at square and y is equal to at to the power 4, how to find dy upon dx? Because function is given in terms of t, so differentiate first of all x is equal to 2at square with respect to t, and similarly y is equal to at to the power 4 with respect to t. So we get dx upon dt is equal to 4at, and dy upon dt is equal to 4at to the power 3. Then you get dy upon dx using the chain rule, dy upon dt divided by dx upon dt, or we can write it as dy upon dt multiplied dt upon dx. So therefore dy upon dx is equal to 4at to the power 3 upon 4at, so is equal to t square. So t square is the first order derivative of given function. Next question, if x is equal to sin t, y is equal to cos 2t, then find dy upon dx. Again, because function is given in terms of t and differentiation of sin x is cos x, and cos x derivative is minus sin x. So dx upon dt, because we are differentiating with respect to t, so dx upon dt is equal to cos t. Similarly, differentiate another function, dy upon dt is equal to minus sin 2t multiply 2, and that you can rewrite it as minus 2 sin 2t. Finally get dy upon dx using the quotient rule or chain rule. You can write it as dy upon dt divided by dx upon dt, or we can write it as like dy upon dt multiplied dt upon dx is equal to minus 2 sin 2t divided by cos t, that is equal to minus 4 sin t. Question number next, x is equal to cos theta minus cos 2 theta, y is equal to sin theta minus sin 2 theta. Function is given in terms of theta, so actually these are the parametric form. Dx upon d theta is equal to minus sin theta, cos theta derivative is minus sin theta, then minus cos 2 theta derivative will be minus sin 2 theta into 2. So therefore dx upon d theta is equal to 2 sin 2 theta minus sin theta. Now differentiate y is equal to sin theta minus sin 2 theta with respect to theta, and we get dy upon d theta is equal to cos theta, derivative of sin theta is cos theta, minus sin 2 theta differentiation is cos 2 theta into 2. So therefore dy upon d theta is equal to cos theta minus 2 cos 2 theta. Hence dy upon dx is equal to dy upon d theta multiply d theta upon dx, or we can write it as dy upon d theta divided by dx upon d theta is equal to cos theta minus 2 cos 2 theta divided by 2 sin 2 theta minus sin theta. Next question, if x is equal to a and within bracket cos t plus log tan t by 2 and y is equal to a sin t. So children, you have to differentiate x is equal to given function with respect to t and y is equal to a sin t with respect to t also. So first of all you write dx upon dt is equal to a is the constant term, you write as it is, cos t derivative is minus sin t plus log tan t by 2, difference will be what? You know log x derivative is 1 upon x. So therefore log tan t by 2 derivative will be 1 upon tan t by 2. Then differentiate tan t by 2, tan x derivative is sec square x. So therefore tan t by 2 derivative is sec square t by 2. And finally differentiate t upon 2 also, which is equal to 1 by 2. T upon 2 derivative is 1 by 2. So therefore dx upon dt is equal to a, within bracket write minus sin t plus 1 upon sin t. How we got sin t? Actually log tan t by 2 is equal to 1 upon tan t by 2 into sec square t by 2 into half, and simplify that we get 1 upon sin t. So dx upon dt is equal to a and within bracket minus sin t plus 1 upon sin t. Children, remember sine 2 theta is equal to 2 sine theta cos theta. But if we reduce the angle by half, if it suppose it is sine theta, so sine theta could be equal to 2 sine theta by 2 into cos theta by 2. So what is this? What is in this question is 2 sine t by 2 into cos t by 2, that must be equal to sine t. So therefore dx upon dt is equal to a, and within bracket write minus sine t plus 1 upon sine t. You take the LCM and then we get a cos square t upon sine t, and finally get now dy upon dt is equal to a cos t. So therefore dy upon dx is equal to dy upon dt divided by dx upon dt, which is equal to a cos t divided by a cos square t upon sine t, and simplify that we get is equal to dy upon dx is equal to tan t. Question number 5. If x is equal to a cos theta plus theta sin theta and y is equal to b sin theta minus theta cos theta. So children, here we are getting theta sin theta and theta cos theta. It means we have to apply the product rule in this question. You know, suppose u and v are the two functions. What is the product rule? You write first function multiply differentiation of second function plus second function into differentiation of first function. Listen carefully. In case of the product rule, let u and v are the two function, then differentiation of uv is equal to u multiply d upon dx of v plus v multiply d upon dx of u. So same formula you are applying in this question, because we have theta sin theta and theta cos theta. So okay, x is equal to a cos theta plus sin theta. So therefore differentiate with respect to theta, dx upon d theta is equal to a, and write d upon d theta cos theta and d upon d theta theta sin theta. So dx upon d theta is equal to a minus sin theta plus theta you write as it is, and sin theta derivative is cos theta. It means we are getting theta into cos theta plus sin theta into 1. 1 is y. Theta derivative is 1 with respect to theta. Then you get down dy upon d theta is equal to b, and within bracket write sin theta derivative is cos theta. Cos theta minus, and again apply the small bracket there now, theta into minus sin theta plus cos theta into 1. 1 again, it's the derivative of theta. So by simplify we get that dx upon d theta is equal to a theta cos theta, and dy upon d theta we get a theta sin theta. So finally we get dy upon dx, first order derivative, dy upon d theta divided by dx upon d theta is equal to a theta sin theta divided by a theta cos theta, and a theta divided by 1, so is equal to tan theta. So therefore the dy upon dx first order derivative result is tan theta. Thank you so much, children. I hope you understand all this.